Hey, what's up everyone? So today we are going to be talking about wiring our robotic arm to the Arduino, and we're going to talk about setting up our base program, ultimately to be able to move chess pieces around a chessboard autonomously. So you needed to already go through my wiring video for the robot arm. So if you're at this video and you haven't done that yet, then go back and check out my video from before. And we'll start from there. You're going to need an Arduino from me, and you're also going to need the power supply like we talked about last time. So again, make sure when you rewire your power supply that you're confirming that your positive and your negative bus bars are aligned just like we did in the last video. So where we left off here, I had programmed my I had wired my positive with the green wire and my negative with the blue wire. Again, I have all of my wires coming out for my 4 different servos. We have the claw, the left, the middle, the right. Okay, and all those come to these pins down here. Notice how I haven't separated all my wires, but I did pull the 2 wires that go to power away from the others a little bit more because they need to go to a different part in the board. If things keep popping out, kind of like mine do, just keep putting them back, okay? You can even maybe like move the position that we connect to. So on our board, on the one side here, let's see if we have our power, okay? And if you take a look at this, there is 2 ports, and it's going to be hard to read on mine, but look at the side of yours. There are 2 ports that say ground. They have like this white around them. And then to the side, there's one that says VIN, which VIN stands for voltage in. We are going to supply ground and voltage to the Arduino from our breadboard. That's one of the ways. We need a continuous ground throughout the entire system. And we are going to get that from down here. Now on the opposite side of the board, we have our digital I/O ports. This is going to be where our servos attach to. And again, if you look, they're numbered 0 through 7, then there's like a small gap. And then there's 8 through 13, there's another ground and some other things going on. We are going to be wiring today in 8, 9, 10, and 11. Alright, and they're going to be in the same order that they were in the breadboard. 8 is the claw, 9 is the left motor, 10 is the middle motor, 11 is the right motor. So, when I go to take my 4 pins, they're already in order. I'm going to plug those in there. Okay. Then my blue is negative, my green is positive. So on the opposite side, blue is going to go to ground. Green, in my case, is going to go to VIN, okay, or voltage in. So now that I have that set up, it's time to power up the system. So the first thing we're going to do is we're going to plug in a 9-volt power supply into the breadboard. Alright? There are no lights that come on. There is, difficult to see in the video right now, there is a on-off switch over here. We should see some red lights going on there. We should also see on going on over here. And I have a base code loaded onto my Arduino right now, which I'm going to ditch for the moment and come back. Alright, so things have stopped moving. We're going to open up the Arduino program. So we're going to go to Arduino. It should be on your desktop. We're going to open up the software. Now I have the USB plug that comes with the Arduino. That's plugged into the Arduino port itself, and then the opposite end is plugged into the computer. This is our base sketch. That's what this is called here. We have our void setup. Everything that happens between these two brackets is within void setup. Everything that happens between these two brackets is in void loop. Loop is going to repeat many, many times. Void setup is only going to repeat once. When we're using the controllers, if you get to that point, a lot of that code is going to be in void loop because we want to be able to read the controllers and then change the output. For today, and for the first activity with the chess pieces, most of our code, if not all of our code, is primarily going to be in void setup or even a little bit above. So let's get started here. We're going to go to line 1, the beginning of line 1, and we're going to go to sketch, and we're going to include a library, and we are going to include the servo library. So that brings in this line of code here, include servo.h. We're going to go to the end of that and create a new line, and we're going to add our name to the code. Now, if we were just to type our name, this would later give us an error, and it would say like, hey, this isn't an actual code, there's a problem here. So it's like trying to compile my sketch right now, which sometimes can take a while. In order to avoid that issue, we need to turn this into a comment. Comments are produced the same way down here, where it says put your setup code here to run once. We put 2 backslashes, and that's going to turn this into a comment. So I comment in my name. Next line, I'm going to comment in my program name, which this is robot arm base sketch. We're just going to leave it at that. So the first thing we want to do is we want to set up, and 10 minutes later, there it is, it's giving me my error. Okay, I already fixed it. I'm just gonna move on. Alright, the next thing we need to add is a servo class. Okay, so we're gonna type capital S-E-R-V-O. This is gonna be how we name our servos. So we're going to name one servo claw. We're going to add a comma to separate it out. We're going to add another servo named left, another servo named right, and another servo named middle. And again, there's a comma between each of those. So basically, this comma just repeats the process. So it's like servo named claw, servo named left, servo named right, servo named middle. We're going to put a semicolon at the end of every line of code that we produce. And that allows the computer to know that that line of code is done and to execute the next line of code. Good coders add comments to things. So we are going to add comments to our lines. Name of the 4 servos used. Alright. So that's all we really need up there. Now I'm going to run into void setup. So one of the first things that we need to do in void setup is tell the system where our digital pins are connected to. So again, we're connected to 8, 9, 10, and 11. So in order to do this, we are going to name our servo first. So call the name of the servo. So this is the claw servo. We're going to put a period in, or what I'm going to refer to as a dot for the most part. So claw dot attach. And the claw, it should be in pin 8. You can confirm that, but within parentheses, we're going to put an 8. Again, we are going to add a semicolon to end the line, and then we're going to also add a comment afterwards that says the claw servo is in pin 8. Now, copy and paste is a programmer's best friend, so I'm going to copy this. Paste this 4 times, and I'm just going to rename and change some of the attributes. Okay, so we have claw, we have left. Left is in 9. I'm going to rename this. Left servo is in pin 9. We have our middle, which is attached to pin 10. Alright, so that's where we're at right now. So we got, again, a claw is attached to 9, claw is attached to 8, left attached to 9, middle attached to 10, right attached to 11. It's time to center all of our servos to start at like our base position. So again, the left, the right, and the middle, their base position is 90 degrees. The claw's base position is 45 degrees. So in order to like make servos move, we are going to use the right command. So again, standard servos go from 0 to 180 degrees. So we're going to say, first of all, claw, or any of them, dot right with a W, like we're writing something on a piece of paper. And then in parentheses, we're going to add like what angle we want it to start off at. So we're going to start our claw off at 45 degrees. We are going to set our left dot right to 90 degrees. And we're going to repeat that process for the rest. Now, if you get all these extra spaces, honestly, it doesn't matter, but from like an organization perspective, it looks better to have things kind of in the same line. Technically, if statements and other like logic is going to move over later on, but for right now, we're not going to worry too much about that. So the right and the middle. Alright, so let's verify our code. So by verifying our code, it's going to go through our code, it's going to check it. Sometimes this process will be fast, sometimes this process will take a couple minutes. You can see in the bottom right hand corner, this like green taskbar sliding through. It's checking to see if there are any errors in the code. If there are errors in the code, it's going to highlight what the issues are, and you're going to like double check your code and make sure that it's correct. So right now everything seems to be correct, and I now need to connect to my Arduino. So up in Tools, again I'm already plugged into the Arduino with my USB cords. Up in Tools, we are going to come down to Ports. I have lots of ports because I've connected lots of Arduinos, but you're really probably just going to have one or two. Whichever one you want to use is going to say Arduino Uno next to it. So select that COM port. That's like the way that information gets sent across the USB cable. And then the upload button is right there. So we're going to press upload. And again, we may need to wait a few minutes for this code to actually transfer over. All right. So here we are, we're set up, our system is in a default position at this point. So we're going to start like manipulating some code, we'll see if we can see some things move, and then we're going to talk about what you're going to work on. So like let's say like let's close our claw. So we're going to add a pause, which is called a delay, at the end of all of this for 1,000 milliseconds. So this is going to pause for 1 second before moving on. Then from here, let's work on claw. So claw.write, I believe that in the past I've used about 100 to close the claw. We want the claw to almost close. We don't want the claw to be closing so much that it is pressing on itself. So let's see if, like, what kind of happens. Even if I, like, manipulate, which I gotta turn some stuff off. If I manipulate this claw, like this whole system to be like kind of closed, you'll be able to see what happens when I connect this up. It goes back to its default position. I'm then gonna like upload, which you didn't have to do that, but I just wanted to show you. While we upload this, we're gonna see it again in its default position. And then the claw, a second later or so, should close. So we're still loading code. Code just finished loading. Things are moving. There's my claw. My claw's almost closed, but not quite closed. So let's modify the code to make that a little bit better. Let's try 105. We'll upload again. So as we start going through this, you're going to want to start to make notes of like what things control your different like motors and your different pieces. Like there, my claw's a little bit more closed, so that's pretty great. If I hit the white reset button over here, it's going to like restart my code. So if I push that, it's going to open. And there I just stuck like a bishop or one of the chess pieces into the claw, and it's now like holding that chess piece up. So like let's say that we wanted to pick the arm up. That is the left hand side. So let's try and like pick that bishop up. So we are going to say left dot right. And like honestly, you're gonna have to play around with this. Again, the middle right now is 90 degrees. Going up could be closer to like 180 degrees. Going up could be closer to like 0 degrees. Until you start messing around with it, you're not going to be 100% sure. Let's try and go to 150 degrees with that and see what happens. We're probably going to drop the chess piece when the system starts. I missed the opportunity to put the bishop back in it, but that did in fact lift my arm up. Left lifts the arm up. As that thing pivots, that lifts the arm up. Right moves your arm in and out. So like let's try to move the arm back now. So go back to now right. Dot right, which is confusing, and I'm guessing that it needs to go below 90, so let's check that. So let's upload. Oh, missed being able to catch it, but that did, right? It brought that thing back. So we are going to start working on like a chess activity. I guess we can talk about moving it to the right and to the left too. So again, that would be middle, to the right and to the left. Let's also like close our claw, wait a moment before we move on to the rest. Maybe like half of a second. We're gonna say middle dot right, and let's just move it to like 45 degrees, right? So it's gonna pivot us over. So let's upload that code. Cool. Missed it, so I'm going to hit the reset button. It's going to go back to its main position. Missed it again. There we go. Right, now it has moved the chess piece over to there, right? So again, if I press reset, it'll like drop it, it'll pick it up, and it will move it. So that's all pretty good. Let's talk about like setting up our chessboard.